I want the equation of the tangent line, I have to have a point and I have to have slope. And we know that what? We calculate the derivative to find the slope, right? So that's always the first step. So you calculate your derivative, f prime of x. All right, you look at the function. Since we just learned chain rule, this now has chain rule. So I'm going to pull down that 3 in front. I'm going to leave the inside of the function alone. So 4x minus 1. I'm going to remember to subtract 1 from that exponent and then times the derivative of that inside function, which is the 4x minus 1. I still use that ddx notation, even though this is a relatively simple one. On the complicated ones where there's more than one chain, yes, but like on this one, you could have just went ahead and wrote down 4 because it would have been easy to do that. I'm going to keep the 4x minus 1 to the second power, taking that derivative there, which is a 4. So yes, this one would have been real easy for you to not write that line of that ddx notation. So we've got a derivative of 12 times 4x minus 1 to the second power. All right, so there's my derivative. That's my slope at any point along the line. Now I want to plug in 0. All right, notation is extremely important. So f prime of 0, because I'm plugging that into the derivative. That tells the person that's grading your paper you're taking 0, putting it into that derivative. So 12 and then 4 times 0 minus 1. Let's see, negative 1 squared is 1. So just 12. And then once you get your slope, which is 12, and you use your point. All right, we're always going to do point slope form. So y plus 1 equals 12. 12x. Yeah, 12x. Okay, so but if you wrote it x minus 0, that's fine. You could clean it up a little bit. Could we subtract 1 and not screw this up? So like y equals 12x minus 1. I mean, under normal circumstances, I would tell you to leave it in point slope form, but with that being a 0, negative 1, that's a little tacky. Go ahead and go that slope intercept form. All right, now you will have to do this with trig functions. And that means that then you're going to have to know your trig values. If you plug in, like, if the point was pi over 3 something, you'd have to be able to find pi over 3. Okay, so the first quadrant of the unit circle definitely needs to be memorized, and you can use your hand thing for the, sine and cosine. And I would definitely know the 4 points all the way around the unit circle. The rest of the unit circle, you're probably safe not knowing. Okay, so let's do another one. Let's have some trig functions in this one. Let's do one more. Let's do f of x is equal to 2 sine x plus cosine 2x. And let's say our point is pi 1. Okay, so we do have a chain rule right here. All right, even though I didn't put the set of parentheses around it. That's cosine of 2x. There's your inside function. There's your outside. This is just regular constant multiply rule, straight derivative there. Okay, so f prime of x. 2 is going to stay. Derivative of sine is cosine 2 cosine x. All right, this is going to be chain. So I'm going to do the derivative of the outside function first. So derivative of cosine is negative sine. Leave the inside alone. Times the derivative of the inside. Since the inside is 2x, we'll just go ahead and write down the derivative, which is 2. Okay, so if I clean that up, 2 cosine x minus 2 sine 2x. Okay, that's my derivative at any point along the curve. Okay, now you're going to plug in pi. So this is where you're going to need to know unit circle values because you're going to have to do this. So plug in pi. So 2 cosine pi minus 2 sine, and then 2 pi. Okay, cosine pi, think of the unit circle. It's the point on the left. So cosine is negative 1. Someone said negative 1. Think of your unit circle. Right here's pi. That point is negative 1, 0. So cosine's got to be negative 1. So evaluating this, 2 times negative 1 minus 2 times, all right, where's 2 pi? All the way around, right? There's 2 pi. That ordered pair is 1, 0. I want sine, so sine is 0. There's cosine, then sine. Okay, so that one's 0. All right, so that goes away. So my slope is negative 2. So there's slope. I've got slope and I've got a point. Okay, I've got the point, pi 1. I've got a slope. So if we do our equation of our tangent line, let's do it in point slope form. Y minus 1. Slope is negative 2. And then x minus pi. All right, and really, in all honesty, there's no reason to rearrange that. I believe the textbook did, like for a textbook answer, they went ahead and distributed the 2 and moved the 1 over. I see no point in doing it. Point slope form is fine. Okay, point slope form is fine. Okay, so that's the only thing I wanted to do to review those two things before we started looking at functions and derivatives. Okay, are we good on the equation of the tangent line?